Good morning. Welcome to today's Meet the Author event. Many of you are from our two sponsoring congregations, Addis Israel and Bethel, and many of you are from other synagogues or the wider community. All of you are very, very welcome. I'm Robin Jacobson, the librarian at Addis Israel, and with me is Marge London. Marge and I co-facilitate Bethel's book club. This morning, we are very excited to welcome Dr. Avi Loeb from Lexington, Massachusetts, to present his new book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth. You'll hear more about Dr. Loeb in a moment. But let me just say that Extraterrestrial is an eye-opening read on so many different levels. It's about a farm in Israel. It's about an elite science track in the Israeli army. It's about the way we try to expand knowledge in science and in other fields. And it's about the mysterious interstellar object that streaked through our solar system in 2017. In honor of Avi Loeb and as a salute to the search for knowledge, my Zoom background shows the Pan-STARRS telescope in Hawaii. This is the telescope that first spotted the tantalizing interstellar object OUMUAMUA in 2017. That Hawaiian name translates into a messenger from afar arriving first. How thrilling. A quick word about coming attractions. Next month on Sunday, July 25th at 11 a.m., we'll discuss The Lost Shtetl by Max Gross. This is a fun summer book about a Jewish village in Poland that time forgot. And then, since this is a crowd with an interest in science, here's a heads up that our first author visitor in the fall on Sunday, October 3rd, is MIT professor Sherry Turkle. Dr. Turkle will be talking about her memoir, Empathy Diaries, and about the inspiration she found in Jewish Brooklyn for her pioneering work in the study of people's relationships with technology. If you're wondering whether you control your phone or your phone controls you, you might want to check out this program. And now Debbie will introduce Dr. Avi Loeb, but give me just a moment, Debbie, to spotlight you.
Oh, okay.
There you go.
Thank you, Robin. It is really an honor to introduce you to Dr. Avi Loeb. After reading his book and our group discussing further, we have more questions than answers. So we're delighted, Dr. Loeb, that you are joining us today. Avi Loeb is the Frank B. Baer Jr. Professor of Science at Harvard University, where he was also the longest serving chair of the Astronomy department. And it was in that capacity that it occurred to me that my nephew's wife might well know Dr. Loeb as she got her PhD there. And lo and behold, I discovered that not only did she know him, he was in fact her thesis advisor. So we are most fortunate. Professor Loeb grew up on his family's farm in a moshav, I think, in Israel, and received a PhD in plasma physics at age 24 from the Hebrew University of Jerusalem. Subsequently, as a long-term member of the storied Institute for Advanced Study in Princeton, New Jersey, he started to work in theoretical astrophysics. In 1993, he moved to Harvard University, where he was tenured 3 years later. Dr. Loeb was the founding director of Harvard's Black Hole Initiative and is the current director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. In 2012, Time selected Loeb as one of the 25 most influential people in space. I presume, though, on Earth. Dr. Loeb is the author of nearly 800 scientific papers and multiple books on a wide range of topics, including black holes, the first stars, the search for extraterrestrial life, and the future of the universe. His most recent book is the New York Times bestseller, Extraterrestrial, which he will discuss with us this morning. Thank you, Dr. Loeb, and please go ahead when you're ready.
It's a great pleasure to join you. Let me just share my screen and I will open up the slide presentation. And If you were to ask me to speak it in Hebrew, I would be glad to do so. But at any event, this brief discussion that we'll have concentrates on the book Extraterrestrial that appeared at the end of January. And you can see it in the middle of this slide. And if I had to summarize the book with one sentence, I would say, when you are not ready to find exceptional things, you will never discover them. And that was the subject of a Scientific American essay that I wrote last year. And you can find my views posted every week in Scientific American. I have a commentary column there. What you see on the right side is a book that is about to appear in 2 weeks, actually, to be published by Harvard University Press, titled Life in the Cosmos. More than 1,000 pages long. It's mostly a research manuscript intended for scientists that will attempt to search for life elsewhere. And what you see on the left side is a photograph of a picture that was hung on the wall of the Berlin Brandenburg Academy of Science and Humanities in October 2020. It was taken by a German photographer, Herlinde Quilbel, that came to my office at Harvard and asked me to write on the palm of my hand a question that I regard as the most important in science. And I wrote, "Are we alone?" And the general lesson that I've learned from practicing astronomy for several decades is a sense of modesty, being humble. Because we are born into this world like actors put on a stage without any sense of what the play is about. And the first thing we notice is the stage is huge. It's the entire cosmos. It's 10 to the power 26 times bigger than the size of our body. So we are clearly not at the center of the stage like the ancient Greek philosopher Aristotle used to argue, and people believed him for 1,000 years. Because it flattered their ego. We are not at the center of the stage. And moreover, the play has been going on for 13.8 billion years since the Big Bang. And we just came at the end. So clearly the play is not about us. And that gives you a sense of modesty. But perhaps we can search for other actors. And they know, they have a better sense of what the play is about. But just to demonstrate the sense of modesty that I got, it was enhanced by the death of both my parents over the past few years. Let me give a couple, read a couple of paragraphs from the book. My father David was laid to rest in the same red soil in which he planted trees all his life, in the vicinity of those plantations that he watered routinely, near the house that he built with his rugged hands and that I grew up in, surrounded by the people he loved and who loved him in return, under the blue sky that I study as an astronomer. My mother, Sarah, who put me on the road to thinking as a philosopher, with whom I spoke daily throughout my adulthood, and who especially gifted me with a life of the mind, was buried beside him 2 years later. In astronomy, we realized that matter takes new forms over time. The matter we are made of was made in the hearts of massive stars that exploded. It was assembled to make the earth that nourishes plants that feed our bodies. What are we then, if not just fleeting shapes taken by a few specks of material for a brief moment in cosmic history on the surface of one planet out of so many? We are insignificant, not just because the cosmos is so vast, but also because we ourselves are so tiny. Each of us is merely a transient structure that comes and goes, recorded in the minds of other transient structures. And that is all. We now know from the Kepler satellite that about half of the sun-like stars host an Earth-sized planet roughly at the same separation. So it turns out that in the Milky Way galaxy alone, there are tens of billions of Earth-Sun systems, just like ours. Not only we are not at the center of the universe, but also what we find in our backyard is very common. There are more habitable Earths in the observable volume of the universe than there are grains of sand on all beaches on Earth. So that should give us a sense of cosmic modesty. But when you look at a king like the one portrayed in this painting, he was very proud of himself by conquering a piece of land. But that was no different than an ant hugging a single grain of sand on the landscape of a huge beach. It's not very impressive. But I can understand where it's coming from, because when I watched my daughters when they were young, they tended to think very highly of themselves. They thought that they are the smartest in the world, that the world centers on them. And when we took them to the kindergarten, they got a better perspective. They found other kids that may be smarter than they are. So our civilization will mature only when we find others. And for that, we need to go to space. And we're probably not the sharpest cookies in the jar. And by the jar, I mean the Milky Way galaxy. And the reason I say that is by reading the morning news every day. We waste a lot of resources on fighting each other, on trying to feel superior relative to other people. And that's not a sign of intelligence. The way I define an intelligent species is a species that follows the guiding principles of science, of cooperation, and sharing evidence-based knowledge. We don't do that very often. In my book, I talk about Winston Churchill, that in 1939 wrote an essay encouraging humanity to search for extraterrestrial life. And shortly afterwards, he didn't have a chance to publish the essay because he was drafted to become the prime minister in the UK to fight the Nazis. And just think of how many resources were wasted in the Second World War. The US alone had to spend $4 trillion, and 75 million people were killed, 3% of the world population, and 2/3 of the Jewish population in Europe. 6 million Jews were killed. So if all of these resources were instead of being wasted, were dedicated to pursuing Churchill's vision, we could have known by now whether we are alone or not. Now, Earth is our home, but only for a while. There are internal threats associated with self-inflicted wounds like climate change, nuclear wars that we might have, or pandemics, all kinds of political or technological catastrophes. And there are external threats. 66 million years ago, the dinosaurs were very proud of their huge body. They were dominant relative to their environment. And then a big rock the size of Manhattan Island hit the ground and tarnished their ego trip abruptly. And so that's another risk. And eventually, within 1 billion years, the sun will boil off all oceans on Earth. So we better spread our eggs in more than one basket. Right now, everything that is precious to us is here on Earth, and we should venture into space. So let me, in a few words, mention my journey from the farm in Israel to space. I'm fundamentally a farm boy. All the labels that were mentioned in the introduction are not so significant for my daily routine. I just think about the world like a kid. And I grew up on a farm, as you can see on the top left, was born 59 years ago. I used to collect eggs every afternoon. We had chickens, as you can see in the second image. I used to drive a tractor to the hills of the village, Moshav, and read philosophy books. Philosophy attracted me because it addresses the fundamental questions that we have, unfortunately, most of the time without providing a good answer. And one thing led to another. I ended up at Harvard, and in May 2015, a black limousine parked in front of the Center for Astrophysics at Harvard, and out of it came an entrepreneur from Silicon Valley named Yuri Milner. And he entered my office, sat on the sofa in front of me, and asked me whether I'm willing to lead a project to visit the nearest star, Proxima Centauri, within his lifetime. And since he is the same age as I am, that meant within 20 years. And I knew that light takes 4 years to get to the nearest star. So we need a spacecraft that moves at a fifth of the speed of light if we want to get there in 20 years. And that meant 1,000 times faster than all the spacecraft that we've launched in the past. A factor of 1,000 is roughly the ratio between the speed of a spacecraft and the speed of Henry Ford's T car, the first car. So that seemed to be a challenge, but 6 months later, I came back with a proposal to Yuri, and we announced a project called Starshot in April 2016. You can see that in the middle bottom image, where Stephen Hawking came for the inauguration. He also came for Passover at my home in Lexington, and you can see also Freeman Dyson, who passed away since then. This is a picture of the solar system. You can see that the biggest volume of the solar system is actually occupied by the so-called Oort cloud, which is a collection of all the bricks that were left over from the construction project of the solar system. These are rocks floating around, and every now and then one of them comes close to the sun, and since it's covered with ice, the ice evaporates and it looks like a comet. And the Oort cloud goes roughly halfway to the nearest star. The nearest star is Proxima Centauri. It's 12% the mass of the sun and half the temperature, the surface temperature of the sun. So it emits mostly infrared radiation. And since it's so faint, the habitable zone, the region where you can have liquid water on the surface of a planet, is actually 20 times closer than the Earth is from the sun. And miraculously, there is a planet there. It's called Proxima b, roughly the size of the Earth. And since the planet is so close to the star, it faces the star only with the same side at all times. So it's tidally locked, just like the moon faces us with the same side at all times. So there is a permanent day side and a permanent night side on this planet. And my daughters say that if we ever go there, they want to have a house in the strip that separates these two sides, because that's where you can see the sunset forever. Just imagine sitting on the porch and seeing the sunset forever. And since this planet receives mostly infrared light, I asked the students in my class whether they know of any creature that might live there that has infrared eyes. And one of them found a shrimp on Earth that has infrared eyes. You can see it, I put it in the middle of this image, and it has eyes that look like two ping pong balls, and it does look like an alien to me. So how do we get there and check whether there is life? The proposal was to push a very thin film of material, a sail, but instead of pushing it with the wind, as often on a boat, you push it by light. So light bounces off it, reflects off it, and gives it a push. And you need a very powerful laser beam. And then you can attach electronics. And if this sail weighs roughly 1 gram and is pushed by a very powerful laser, within a few minutes, it can reach a fifth of the speed of light. So this is an artist's illustration of a mother spaceship releasing a sail above the atmosphere so that it will not encounter the friction. And then an array of low power lasers produce a coherent beam that shines on it. The size of the sail is roughly the height of a person, a few meters, and it weighs about 1 gram. And over a few minutes, a laser of 100 gigawatt can push it to a fifth of the speed of light across a distance that is 5 times the distance to the moon. And so even though it takes only a few minutes to reach a fifth of the speed of light, the next phase of the journey takes 20 years to reach Proxima Centauri. So it's a very long journey. And all these stories that you find in science fiction make little sense. The journeys are really long and humans will never embark on them. And then the idea is by passing close to the planet, we can take a photograph and then send the signal back to Earth. This project is called Starshot. But the real question is not so much whether there are microbes on other planets. We want to know whether we are the smartest kid on the cosmic block. And when I look at recipe books, you can see that out of the same ingredients, you can make very different cakes. So it's quite unlikely that out of the soup of chemicals that existed on the early Earth, we represent the very best cake possible. That's why a sense of modesty is in place. But without a prejudice, the best approach is to just be open-minded and search. It's a fishing expedition. You don't know what you will find. And the best place to start the search is in our backyard. And it turns out that the first object from outside the solar system was identified close to Earth in 2017 by a telescope called Pan-STARRS on the summit of Mount Haleakala in Maui, Hawaii. And it was given the name OUMUAMUA, which means a scout in the Hawaiian language. You can see it here circled in blue. And it came from a very special direction. It's the direction that the sun is moving towards in the local frame of the galaxy. So if you average over the motions of all the stars in the vicinity of the sun, you get to the so-called local standard of rest. And Oumuamua was at rest in that frame, sort of like a buoy sitting at rest on the surface of the ocean, with the sun like a giant ship bumping into it. And that's a weird property because only 1 in 500 stars is so much at rest in the local standard of rest. So already it looked a little bit unusual, this object. And then as it was tumbling every 8 hours, the amount of light that was reflected from it from the sun acts like a lamppost that illuminates the darkness in our vicinity. And the big enough objects, the size of a football field, can be observed by reflecting sunlight. But as this object, Oumuamua, was tumbling, spinning, the amount of light that it reflected changed by a factor of 10. And that meant that it has a very extreme shape. And the best fit to the variation of light reflected from it was that of a flat object, pancake shape. And that's unusual. We usually, asteroids do not change by more than a factor of 3 in the amount of light that they reflect. And it had some other strange properties. In addition to coming from the local standard of rest and to have its brightness change by a factor of 10, it also had no cometary tail. There was no gas or dust surrounding it like you find around comets. And the Spitzer Space Telescope put very tight limits on carbon-based molecules in its vicinity. So it was definitely not a comet. But then astronomers say, okay, well, maybe it's an asteroid that came from another star. And the problem with that is there was a push on this object, and in addition to the force of gravity acting on it. And it couldn't have been the rocket effect from evaporating gases, because that would mean that at least 1/10 of the object, 1/10 of the mass of the object had to evaporate, and we would see that easily. So what is it that gives it a push? The only other force that I could think of was the reflection of sunlight from it. And for that, it needed to be thin, just like a light sail. But nature doesn't make light sails. So we had a few lines in a scientific paper that was immediately accepted for publication, we said, well, maybe it's artificially produced. And of course, there was a huge interest in this from the public and the media, but at the same time, very strong pushback from the scientific community. And since then, the mainstream scientists that tried to explain the anomalies of Oumuamua, and there were 6 of them that I describe in my book, suggested explanations that involve something that we've never seen before. One suggestion was that it's actually a dust bunny, a collection of dust particles like you find at home that are very loosely bound, and a cloud of dust particles that is 100 times less dense than air, so that it's very lightweight and gets pushed by reflecting sunlight, like a feather. The only problem with this idea is that as the object gets close to the sun, it would have been heated by hundreds of degrees, and it would not have maintained its integrity, wouldn't have the material strength. Then there was a suggestion, maybe it's a piece of a bigger object that was ripped apart by tidal forces as this bigger object passed close to a star. And the problem is the chance of passing close to a star is small. And moreover, if you tidally disrupt a big object, you end up with elongated pieces, not pancake shape. Then there was a suggestion, maybe it's a chunk of frozen hydrogen, so that when hydrogen evaporates, we wouldn't see the cometary tail because it's transparent. And the problem with that is that hydrogen evaporates very quickly. So a hydrogen iceberg would not survive the journey. We show that in a scientific paper. Then there was a suggestion, maybe it's a nitrogen iceberg, a chip from the surface of a Pluto-like planet, because we know that Pluto has a coating of nitrogen, solid nitrogen on its surface. And the problem here, as we showed in a paper with my student, is that there is just not enough nitrogen on Plutos around other stars to account for the discovery of Oumuamua. There is, even if you take all the nitrogen that you find in stars in the Milky Way galaxy, you won't get enough chips to explain the discovery of Oumuamua. So this is an excerpt from one of the early reviews on my book, and I didn't understand a couple of words here, but my daughter's explaining to me. And the way I think about us meeting Oumuamua is similar to finding a plastic bottle on the beach. Most of the time you find rocks or seashells that are naturally produced. But when you find a plastic bottle, it implies that there is a civilization out there. And it turns out that there was another object discovered in September 2020 that was pushed away from the sun by reflecting sunlight and had no cometary tail. It was given the name 2020 SO, discovered by the same telescope in Hawaii, Pan-STARRS. And the astronomers that found it realized it actually is a rocket booster from a 1966 launch of a lunar lander mission. So we know that we produced this object. It had thin walls, and that's why it had a lot of area for its mass, and it was pushed away from the sun. So we know that it's artificially produced. The question is, who produced Oumuamua? There was another interstellar object found in 2019 by a Russian amateur astronomer called Borisov, and it's called after him. And this one looked just like a comet. So I was asked, doesn't it convince you that Oumuamua is natural as well? And I said, you know, when you find a plastic bottle on the beach and then you find a lot of rocks after that, it doesn't make the plastic bottle a rock. Another way to put it is, when I met my wife, I thought that she's special. I met a lot of people since then, and she still looks special. So the fundamental question is, was Oumuamua natural or artificial in origin? And of course, a picture is worth 1,000 words. We couldn't take a picture because it was too far away. In my case, a picture is worth 66,000 words, the number of words in my book. if we had a photograph of Oumuamua, I wouldn't need to write the book. We could have easily told whether it's a rock or an artificial object. And what you see here is a picture taken by OSIRIS-REx, which was a mission to an asteroid named Bennu. And we can tell that the asteroid is a rock. And in fact, OSIRIS-REx took a sample from Bennu and will bring it back to Earth in 2023. And so in the future, if there will be more objects like Oumuamua showing in the sky, we could send a spacecraft equipped with a camera that will take a close-up photo. I'm optimistic about that because when I go to the kitchen and find an ant, I usually get alarmed because I know that there must be many more ants out there. So we will find more of the same, and then we could examine those objects carefully and take a photograph. I'll skip some slides. This is an illustration of the history of the universe, starting from the Big Bang on the left, we are on the right after 13.8 billion years. We just came to exist relatively recently, and most of the stars formed billions of years before the sun. So if they had technological civilizations around them, they predated us. And they could have sent equipment into space, just like we sent Voyager and New Horizons. And it's not just searching for relics, but also one can search for industrial pollution in the atmospheres of other planets. One can search for artificial lights on the night side of Proxima b. This is a paper we posted with with a student from Stanford 2 weeks ago. One can search for photovoltaic cells covering the surface of a planet. They have a special reflectance. One can search for beams of light that are sweeping through our sky and will appear as flashes of light. So there are many technological signatures that one can search for. And of course, these beams of lights may originate from a system like Starshot aiming to push a light sail. But there is another way to get a light sail close to the speed of light. You can park it around a star that is about to explode. And then it's just like surfers on the beaches of Hawaii waiting for a giant wave. In this case, it's a wave of light that is produced by the explosion of the star, a flash of light that will carry the light sails close to the speed of light. And the situation is similar to dandelion seeds that you can see here on the right, which are carried by the wind. So Enrico Fermi, a very famous physicist, asked 70 years ago, where is everybody? And this question to me is presumptuous because it assumes that we are sufficiently interesting for other civilizations to come to our backyard and have a party. When I met my wife, she had a lot of friends that were waiting for Prince Charming on a white horse to show up and make them a marriage proposal. It never happened, so they compromised. There is no reason for us to think that we are sufficiently interesting since we developed our technologies only over the past century. We were not very interesting before that to outside civilizations. And it's quite possible that there is also a very short window of opportunity for us to communicate with them. So trying to detect radio signals makes little sense. It's just like trying to have a phone conversation. You need the counterpart to be alive. And most of those civilizations might be dead by now. But we can search for relics that they left in space. And my hope is that by finding relics from civilizations that perished as a result of misbehaving, we will get our act together and avoid a similar fate. Thank you.